Disney Pictures brings the award-winning book to life. Holes.
My name is Stanley Yelnats. All my life I seem to be in the wrong place at the wrong time. My grandpa says it's because of this 150-year-old curse.
There's no curse on this family.
There is on the men in this family. It's all because of your no good, dirty, rotten, pig-stealing great-great-grandfather. Welcome to Camp Green Lake.
Where's the lake?
This is Stanley.
Everyone in my family names their son Stanley because it's Yelnats backwards.
Well, that's interesting. Did you tell them about the lizards?
You don't bother them, and they won't bother you. Usually.
Now, to break his family's curse,
It's destiny.
you'll have to solve a mystery
What do you say we dig one more hole?
Why?
I feel lucky.
and find what's hidden at Camp Green Lake.
What is that? I think I might have found something.
What'd you find?
You better get down here.
Those cats in the detail that stick together.
Stanley!
My name is X-Ray.
Magnet. Zigzag.
This is Zero.
It's on fit.
Oh, you stink!
No, that's not a joke. That is a clip of the movie Holes, because we are going to be talking about holes today. So I thought that was fun, kind of funny. That's one of my son's favorite movies. That's why I like to throw that on there. But we are talking about holes in the graph today. I will give you a video check on Monday, so hopefully you've watched that and take a look at this. But all I'm going to do is show you how to find the hole, and then we'll go through the whole process of an example on Monday with everything else and the asymptotes and the intercepts and graphing it and all that. But basically, you guys, a hole is really that. It is a hole in the graph. Basically, in order to find a hole, you factor out the numerator and the denominator, and if there's a common factor in both, then we have a hole. So let's take a look at this example here. F of x equals x squared minus 2x minus 8 over x squared minus 4. So if I factor this problem, I'm going to end up with x minus 4 times x plus 2 over x minus 2 times x plus 2. So when I factor this, we see that right off the bat we have an x plus 2 in the top and an x plus 2 in the bottom. Now, based on what we did in the last unit, we would cancel those because one is on the top and one is on the bottom. Now, when we cancel them, it does simplify my function. My function is now x minus 4 over x minus 2, but we can't just cancel them and ignore them because they were part of the original function. So what happens here is when these cancel out, we have a hole in the graph. And here's how we find the hole. We take the factor that we canceled out, which was x plus 2, and we set that equal to 0, and we solve it. So we get x equals negative 2. Now that is the x value for the hole. Now, what we need to do in order to graph the hole is we have to find the y value for the hole. Okay? And this is where it gets a little bit tricky. The x value is negative 2.
Good afternoon,
And
students. If you are in the school
here come the
building
announcements.
and you are not with a teacher or a coach, you must exit the building at this time. Again, all students, if you are not with a teacher or a coach, you must exit the building at this time.
All right, so here we go again, picking back up. The announcements kind of interrupted us, but here's the x value for the hole. And if I want to find the y value, what I do is I plug it into this equation. Don't go back to the original one, because if you plug it into the original one, it's not going to work. You're going to get 0 in the denominator. So I'm going to plug in this x equals negative 2. I'm going to plug it in right here. And when I do that, that's going to tell me the y value for my hole. So when I plug that in, -2 minus 4 is -6, and -2 minus -2 is -4. So that comes out to be 3/2, which is 1.5. That is the y value for my hole. So my hole as a coordinate, the hole for this graph, will be at -2, positive 1.5. Okay? Now, why is that important? Well, I need to be able to graph the hole when I draw the graph for my equation, because I'm going to have to put it on my line somewhere. Now, if you're looking at your graphing calculator, let me show you this. If you type this into the graphing calculator, the original function, x squared minus 2x minus 8, divided by x squared minus 4, and we graph it, our picture looks like this. Okay. Notice we're probably going to have a vertical asymptote in here, which we should, because I still have this x minus 2 there, and I could get a vertical asymptote out of that. But what I want to show you is this. When you go to the table and you find positive 2, or negative 2, excuse me, when you find -2, which we said was our hole, when you find that, notice you get an error message. And the reason you get an error is because we canceled out the x plus 2's and we have a hole there. So now not only are you going to get a hole for, or an error for your holes, you're also going to get an error for your vertical asymptote. So you'll have both of those. Now that will also factor into the domain for our problem. So we'll have to figure out, not only do we have to take vertical asymptotes out of the domain, we also have to take a hole out of the domain. Okay? So in looking at this problem here, if we were going to do sort of what we've been doing, let's just go through our process here. If we were going to find the vertical asymptote here, what we would do is we would look at this. Well, let's just do this. We'll go holes, vertical asymptote, horizontal, slant. Let's just look at it from that perspective. So in this problem, if we were going to do this, we would factor it first. We found out that our hole is -2. We got the y value, that is 1.5. So we would write that as our hole. Okay. Our vertical asymptote, we would go to this problem right here, where we canceled out already, and we've got this. And now we would look at this denominator. And if we set that denominator equal to 0 and solved it, we would get a vertical asymptote at x equals positive 2. For this problem, if we go back to the original, notice that the degrees are the same. You could also look at this problem where we've already canceled. They both have a degree of 1. And if we look at the leading coefficients, again, in either one, it doesn't matter because the degrees are the same. Since they're equal, we look at the leading coefficient, and we have a 1 over a 1. So that is my horizontal asymptote, y equals 1. And since we have a horizontal, we cannot have a slant. So that would be none for the slant. Okay? And what I'll do in class on Monday is we will graph this, and I will show you how to put this hole on your graph. And all we're going to do is basically we'll just put an open circle. That's how we'll represent a hole on the graph. Literally, we'll put a hole in it. So hope you guys have a great weekend, and we will see you on Monday.